Hi, okay, so this is section 10.2, part 2, and it's going to be kind of short. I just want to show you how to calculate the confidence interval and interpret it, okay? And so we're really going to just work with the notes here. So I'm going to go to the chapter 10 notes, and we're looking at this pooled T-interval procedure. The assumptions are exactly the same as the assumptions for the hypothesis test. So we only use this when, simple random samples, independent samples, normal population, or large samples, right? So we need this normality of the X bars. And then we're assuming here that the population standard deviation is equal. As a matter of fact, I probably should step back and make a note about that because I didn't discuss that in the previous video with the hypothesis test. But if we looked at the ratio of the two standard deviations, we see that 4.4 over S2 over S1, right? And is going to be less than 2 because this is about 4.4 and this is about 4.0. And that's going to be a ratio of less than 2. You can just calculate that. So we're in the situation where it's reasonable to assume that the population standard deviations are equal. So for the confidence interval, we're going to use this, this formula. Also on the formula sheets. So take a moment, please, and look at the formula sheet. And for chapter 10, the confidence interval formulas are over here on the right. X bar 1 minus X bar 2 plus or minus T sub alpha over 2 times your pooled standard deviation and this factor here, right? It looks like in chapter 8, in chapter 8, we had S over the square root of N. And so that gets replaced by this more complex, but similar S sub P times this factor. This is like the over square root of N piece. Okay, but it's a little more complicated. And SP is that pooled standard deviation, which we discussed when we were doing the hypothesis test. Okay. So here's our interval, and then we also have to interpret the interval. So the 95% confidence interval for driving distances is going to have this form. We need to look at T, find the T sub alpha over 2 on N1 plus N2 minus 2 degrees of freedom. So that's this value 2.052. As a matter of fact, that's the same value we used in the hypothesis test. So we're going to substitute in our sample statistics, X bar 1, X bar 2, SP, and the T. So subbing in, and guys, it's probably a good idea if you can sub it all in and pause the video and just work through the different stages, okay? When I do these calculations, I always will clarify here, this piece here, SP. This piece here, right? And then multiply it by 2.052, that the T value, okay? It's working through the calculations one step at a time. And in the end, our confidence interval, our 95% confidence interval is minus 4.68 to 1.76. So we're going to interpret that interval in the same way we interpret confidence intervals from chapter 8. We are 95% certain, 95% confident that the difference between the mean VMT in the Midwestern and Southern households is between minus 4.68 and 1.76. Okay, so we notice here that the lower bound is negative and the upper bound is positive. So it is not unreasonable to consider that the possibility that mu1 minus mu2 equals 0 because 0 is in that interval. Okay, so that's it for the videos and the notes for chapter 10. I'll see you in the next class, and I'll see you in the next chapter. Take care.